హాయ్ ఫ్రెండ్స్, మనం ఇప్పుడు పోర్టర్ గవర్నర్స్లోనే ప్రాబ్లమ్స్ డిస్కస్ చేద్దాం. లుక్ ఎట్ హియర్. ఏ పోర్టర్ గవర్నర్ హ్యాస్ ఈక్వల్ ఆర్మ్స్, ఈచ్ 250 mm long and pivoted on the axis. Of rotation. Each ball has a mass of 5 kg and the mass of the central load on the sleeve is 15 kg. The radius of rotation of the ball is 150 mm. When the governor begins to lift and 200 mm, when the governor is at maximum speed, find the minimum and maximum speeds and range of speed of the governor. Okay, so this is the type of problem. Now we are going to see how to solve this one. Now here I put it solution. So then given, so first I am going to write here given data for this. Okay, BP is equal to BD is equal to 250 mm. What is BP, what is BD, we don't know. That's why we are going to here draw the first Porter governor. We know very well this is P, this is B, okay, this is B, and then now this is called W, small w, mg. This is the link D. Okay, here I put it here D. Now here also having weight capital W by 2. Okay, capital W by 2. So here to here distance is given, and now here to here distance is called height h1. So this is the point is called G. Okay, so this is distance is called 150 and this distance is called 250. Now this distance is called 250. So this is the given problem, and then now here I am going to draw what happened after compression. This is ball, now I am going to draw axis. We know very well this is P, this is D, this is G. So this is coming from 200. 150 గా ఉంది, స్లీవ్ అనేది అప్వర్డ్ అయిపోయినప్పుడు 200కి మారిపోయింది. బట్ లింక్స్ ఆర్ సేమ్, లింక్స్ ఆర్ నెవర్ చేంజ్, దెన్ height will change. So I put it here h2. The weight is same, here also capital mg by 2, and now here also small m g by 2. Sorry, not 2, this is w by 2, this is w. Okay, right, that's why here I put it BP that is equal to BD. So both are in 250. Now I am going to convert into meters, 0.25 meters, and then M is given, that is 5 kg. M is given 5 kg R1 is equal to 150 mm, that is 0.15 meter. Okay, and then R2 is equal to 200 mm, so that is equal to 0.2 meter. Okay, right. So this the diagram is called minimum position, and now come to here, this is called, we can write maximum position. Okay, so the minimum and maximum positions of the governor are shown in figure AB. Okay, so now we are going to see minimum speed. Okay, minimum speed when R1 is equal to BG, that is equal to 0.15 meter. BG, this is called R1, this is called R2. Okay, R1, R2. Then let N1 is equal to minimum speed. N1 is equal to minimum speed. So from diagram A, minimum speed, from diagram A, we find that height h1. Okay, we find that height h1 is equal to, here look at this, pg square is equal to pb square minus bg square. Take this triangular, so I can write here, so h1 is equal to pg, that is equal to whole root of pb square minus bg square. Okay, now here substitute the values, and what is pb? pb is 250 and bg is 150. Okay, so here we converted into meters whole square minus bg is equal to 0.15 whole square. Okay, then solve this, we will get the answer in here, 0.2 meter approximately. Okay, now we know that n1 square is equal to small m plus capital M divided by small m into 895 divided by h1. So substitute this all values in here, we get the answer. Oh no, that is coming from here approximately 133.8 rpm. Okay, so this is the answer, right? So now we are going to maximum speed. And then now here maximum speed when R2 is equal to 0.2 meter. So let N2 is equal to maximum speed. So from figure B here, from figure B, okay, we find that height h2. So and a similar procedure, h2 is equal to pg is equal to whole root of pb whole square, so minus bg whole square. Okay, and then now here substitute these values, 25 whole square minus 0.2 whole square, then it will come here 0.15 meter, 0.15 meter. This is called from h2. Okay, and now right, and now h2 is come here, then we go for n2 square, m plus m divided by m into 895 divided by h2. So here is substitute all values, 895 divided by 0.15, that's approximately, we calculate this, we will get rpm. Okay, so this is the procedure to solve the problem. And then we are going to see another one. Okay, another one we are going to see now. So look at this one. A Porter governor has all four arms 250 mm long. Okay, all four arms is 250 mm long. The upper arms are attached on the axis, okay, good, of rotation, and the lower arms are attached to the sleeve at a distance of 30 mm. Okay, from the axis నుంచి 30 mm. Okay, the mass of each ball is 5 kg and the sleeve has a mass of 50 kg. Okay, the extreme radii of rotation are 150 mm and 200 mm. Determine the range of speed of the governor. Okay, right, now here we are going to see this problem. Problem number 2, solution and given. So before draw given data, I am going to draw the governor. This is point P, we know very well, and this is B, this is ball, see here, this is D. Okay, here to here distance is 30 mm is given. Okay, and this is mg by 2, this is mg, here to here is r1, I put it, this is g, to here is h1, and now this is alpha 1, and now this is called beta. Okay, so here is point called as h. Now this is 250, and now here this arm also having 250. Okay, these all are the given data, and then now here we are going to give compress. So this is P, and now this is called B. This is ball, and then mg by 2. This is D. Now here I put it beta. This is alpha. So this is the radius R2. This is 250, and this also 250. Now I put it here G, and this distance is called H. Okay, and we know very well this is 30 is given. Now here this is put beta 2, alpha 2. This is 1. Actually this is also 1, beta 1. Now here 2, here distance is called H2. Okay, now I put it, the first diagram is called minimum position, and this diagram is called maximum position. Then we are going to here write down given data. BP is equal to BD is equal to 250 mm, 0.25 meter, and then DH is equal to 30 mm, that is called 0.03 meter. Okay, and now we are going to see M is equal to 5 kg of ball, and sleeve mass is equal to 50 kg. Sleeve mass is equal to 50 kg is given, and now R1 is equal to 150 mm, R2 is equal to 200 mm, and then now this is called meter, and this is called 0.2 meter. Okay, so this is the problem is given. Now we are going to see in here, we are finding to H1 first. Okay, so from minimum position we are going to take here H1. Okay, so and the previous problem, like previous problem, we are going to solve here. H1 is equal to PG. H1 is equal to PG. That's whole root of BP whole square minus BG whole square. And then this is 250 whole square, 150 whole square. Solution, it will come here 200 mm, and then that is called 0.2 meter. Okay, you can change directly in this betas also, no problem. Okay, and now BF is equal to BG minus FC. That's come from here 150 minus 30, that is equal to 120 mm. Okay, so this is coming to the point in here BF. So where is F? We should know the point F. Here I put it F. Here to here distance. Okay, and then now here also I'm going to draw, this is F. Okay, So here, okay, and then now here I write one thing, since FG is equal to DH. Okay, and now we are going to see here DF. So see the picture in here, D to F. Okay, so D to F. Now D to F is equal to root of dB square minus BF square. Now see this picture, dB square. Okay, dB square minus BF square. This is the triangle. You can take this triangle. Okay, so now all values we know very well. Just I am going to substitute the values. 120 whole square. Then here the answer it will come 219 mm. Okay, and now here tan alpha 1 is equal to Bg by Pg. So alpha 1 is equal to Bg by Pg. So that is called H1. So Bg already we know. So now here I am going to substitute these values, 150 divided by 200, then that is equal to 0.75. Similarly, tan beta 1 is equal to Bf divided by Df. And now here 120 divided by 219. So that is called here 0.5498. Okay. So all values we know. This is beta. So now here this tag is triangle. Okay. So this triangle we know DF value and we know BF value. Okay, right? So here I find DF. Here I find BF. So I substitute in these values. And PG value I find out here. Okay, so BG value is given, right? Okay, now we are going to see here, therefore Q1 is equal to tan beta 1 by tan alpha 1. Okay, so that's we can substitute in here 0.75, that is equal to 0.731. So we know that n1 square is equal to m plus capital M by 2 1 plus Q1 divided by m into 895 divided by H1. So substitute the all values in here. And solve this thing, we will get approximately 208 rpm. Okay, so these all are things we know very well. N1 square is equal to this equation. Okay, in Porter-Gauner we solve in derivation part. And now we go for from figure B, then here maximum position. Okay, then here the maximum position we are going to see n as similar procedure. Okay, previous how we will find in A, minimum value A. Similarly we take this and solve the all those things. And first of all we are going to find H2, so that is equal to PG. I am going to write directly, don't we get confusion, BP minus BG square from diagram. Okay, from diagram PG. Okay, BP BG, this triangle. Okay, right, and then here I substitute the values in here. 250, 200, and then here is 150 mm. So now 0.15 meter is the answer. And now here we go for BF is equal to BG minus FG. So 200 minus 30, that is equal to 170 mm. And now here DF is equal to whole root of DB whole square minus BF whole square. Okay, and then now here substitute these values. 250 whole square minus 170 whole square, and then now here 183 mm. So therefore tan alpha 2 is equal to BG by PB. Same, similar, don't be get confusion. Okay, all our equations are same. I take directly. Okay, and now substitute this 200 divided by 150. So it will come around, this is the value. And now we go for tan beta 2 is equal to BF divided by DF. And then now substitute this 170 divided by 183. So calculate this, we will get 0.93. So therefore Q2 is equal to tan beta 2 divided by tan alpha 2. So substitute these values. We solve this, 0.7 is the answer. And now we know n2 square is equal to m plus capital M by 2 1 minus q2 1 plus q2 divided by small m into 895 divided by h2. And then substitute these values. 0.7, okay, and then 5 into 895, 0.15 is the h value. Look at this, h2 is equal to 0.12, and calculate this, you will get the answer 288 rpm. So 238 rpm. Now range of speed, we are going to see range of speed. So then range of speed n2 minus n1 is equal to 238 minus 208. So what is it, will come around 30 rpm is the range of speed. Okay, so this is the procedure to solve the Porter governor. The main thing is you can draw this diagram, it almost is over. So mainly this diagram is important thing in this type of problems. Okay, we will see some more problems in next class. Thank you.